So now let's apply this to a current events issue that people care about quite a bit these days, more than ever perhaps. That would be global warming. It's been an issue for over 100 years. People have been studying this and debating it, thinking about it, and let's check it out from a perspective of logic and science, okay? So, question says, based on data that's been collected, scientists are extremely confident that global average surface temperatures have been increasing significantly since the Industrial Revolution. In order to see some of the reason why people say this, we could look up organizations that keep track of this data. So let's go to Google. We could do a search for... And look at that, even on Google they have a little message there. Alright, so let's search for global average surface temperature anomaly. When you're looking for graphs and data, a lot of times it's helpful to click the Images tab here of Google. So you click this and all these time series graphs will come up. And they all look, strikingly similar. The reason why they look similar is because in science you have to have reproducibility of your results. So multiple independent organizations all studying the same thing should come to some kind of consensus about their conclusions. If they can't, then we would highly question their claims. But if they can, we would start to have a lot more confidence in their claims. So I used to always show this graph. This one's kind of cool because it shows a trend line. One of the big things we do is make regression models, and this is an example of one. Taking several different data points from different years, all the way back from 1890, the Industrial Revolution era, to today. And what the data shows, at least for this organization, was that they had a difference of about 1.5 degrees Celsius, which is maybe 2 or 3 degrees Fahrenheit. It may not seem like a big deal to us, 2 degrees, what's that? But when you're talking about a global scale, ecologies could be highly affected. Different climate regions could be highly affected by it. Certain animal populations need a constant temperature. And it could have, effects on sea levels and all this stuff, right? You've heard about it in the news, right? But anyways, that's just one organization. But what's cool is I see that there's some new graphs here, like this one, for example. That one's got 4 different organizations, but I saw one in my last class that had 6. Yeah, this one from Wikipedia. So this has 6 different independent, I assume, organizations. And their results are strikingly similar. They disagree a little bit more about the distant past, but as it gets closer to present day, they have a little bit more confidence in what it was. And it's just interesting that all over the world, Japan, Berkeley, NASA, they're all coming to these same conclusions. So, you got to give some respect to what they're saying, at least. But anyways, let's assume that they're right about this, just for an instant. We'll just make that assumption for the purposes of the question. If we assume that evidence for increased temperatures is so overwhelmingly convincing, if we assume that it's true with high confidence, then what we're talking about is an effect, Q. The observed effect is that temperatures are going up, according to the data. So I'll say global surface temperatures are increasing. And a lot of people want to know why, So one possible explanation that's been proposed is that emissions of carbon dioxide due to human activities have increased, and maybe that's the reason why it's happening. So that would be P. P could be perhaps CO2 concentrations in the atmosphere have increased. We could have other explanations though too, R, S, and T. So R is another proposal that's been made, that perhaps agricultural methane emissions have increased. And that's cows passing gas, apparently. Agricultural methane. It's another greenhouse gas that could contribute to this problem. We could have S, which is the sun's average solar output has increased. We could also have T, which is that volcanic activity has increased. All of these four things, I believe, are logically plausible or reasonable possible explanations for the effect. And so this is part of a certain type of reasoning, is brainstorming about why something is occurring. And we always have to acknowledge, like, is this an exhaustive list? Like, this is the only possibilities that it could be? Well, in the fishbone diagram, we always acknowledge that there could be some other explanation that we didn't think of. It could be something as crazy as a fairy performing magic on the atmosphere, making it hotter because fairy just hates us or something, you know? Maybe. Okay, but a lot of scientists have zeroed in on one of these as the most likely cause. The reality is that there could be a combination of factors that are leading to higher temperatures. It doesn't have to be just one of these things. It could be a little bit of this, a little bit of that. We don't know at this point. We're just making the diagram. But a lot of scientists, blame this one. The CO2 in the atmosphere, probably most talked about potential cause. When scientists guess that P is the most likely cause for Q, what type of reasoning are they actually using, now that you know the three types? Is abductive. Abductive, when you brainstorm about the causes for effects and then pick one. You're making an educated guess. It's part of a hypothesis. So that's abductive to do this. All right, once you zero in on the thing that you want to test, the next step in the scientific method would be to make a experiment. So what you'd really like is you'd like to see if the global surface temperature is a dependent variable on P. Okay, so what you want is you want to make an experiment where P could be the independent variable. Okay, but let me explain what's an issue with that, though. The only way to do a true experiment would be this. You would have to have a parallel universe where you have Earth in 2023, our year, where there is a lot of CO2 in the atmosphere, perhaps. And then you'd have to get a parallel Earth also in 2023. In there, you have to somehow change the atmosphere's composition. You could maybe have an Earth with less CO2 if you were somehow able to remove it. Or maybe you took extra steps to remove it a few years down the line in the future, whereas here they didn't take the steps. Or perhaps you just put more into it than you had originally. But you got to compare where there's a difference of atmospheres. It's the only way to truly know. Why is it the only way to truly know the effect? Because even though you could compare, even though you could compare the Earth of today to the Earth of the past, the conditions here today are not the same as the past. Before 1890, we didn't have the same sun that we have now. It might be burning hotter now than it was then. And you don't have the same volcanoes, and you don't have the same number of cows either. So comparing the past to today does not really eliminate the influence that these confounding factors would have on the situation. The only way to truly eliminate them would be to compare an Earth that has CO2 in the atmosphere versus an Earth that doesn't. And it has to be a parallel universe, so it's the same Earth. Okay, so this is of course impossible. Nobody can do this. What we can do, though, is the next best thing. which would be either to compare the conditions now to the conditions of the past, or another next best thing would be to look at the situation in a lab. So this is an easy experiment to do. People do it all the time. You could have a container of just normal air, and then a container that's filled with a greenhouse gas such as CO2. And what you could do is just shine a light on them. What happens inevitably every time is that the container with the CO2 rises in temperature. Now, is that a true experiment, would you say? I would say it is. It is a true experiment because there's control. There is not control when you're looking at the past versus the present. Here, you do have control in the lab. But the problem is, the lab is just a room. It is not the larger atmosphere. It's not the whole world. And you can't necessarily say that what happens in the lab is going to necessarily be the case for the wider world, because the conditions out there are different than they are in the lab. So my point is that people can never do this experiment. It's impossible to do a true experiment. All you can do is an observational study of perhaps what had happened in the past versus today. You could look at what happens in cases of the lab versus what it might be like out there in reality, okay? But, however, if you do this in the lab, and every time you take the action of P, that would be increasing the CO2 of the container. Every time you do that, perhaps, it leads to Q, which is the temperature goes up. You can see that occur in the lab over and over again. And eventually you might come to the general conclusion that every time P occurs, Q will follow. So if you observe P and observe Q and observe P and observe Q, eventually you'll just say, well, this is always going to be the case. So every time CO2 is added to normal air, the temperature goes up. Even in the wider world, perhaps they may claim. What type of reasoning is it really when they're making a generalization like that from specific cases in a lab, let's say? Abductive, inductive, or deductive. It is inductive to do that. My whole point of this, one of my points, is abductive reasoning. Is it 100% certain? It is not 100%. It never is by its nature. Is inductive reasoning 100% certain? It is not. So, which is correct down here? Should we say that although increases in the amount of carbon dioxide in the air due to human activity appears to be a highly likely cause for increasing global average temperatures, it doesn't prove with 100% certainty that it's definitely the cause? Or should you say that if it appears to be the cause for the increased temperatures, then that proves with 100% certainty that it is the cause? What do you think? First one or the second one? It's the first one, yeah. It's supposed to be the first one, yeah. And you can have high confidence, but not 100%. Okay?